Okay, day 4 notes 8.3. So basically, last time I already told you that the quadrilateral was a parallelogram, and since I told you the parallelogram, then you were able to tell me the properties of a parallelogram. So now we're just going to kind of reverse those things, and we're going to start off with the properties, and if the quadrilateral has the correct properties, then you're going to be able to conclude that it is a parallelogram. So again, the ways to prove that it is a parallelogram is to show that both pairs of opposite sides are parallel. Also, both pairs of opposite sides are congruent. Show that both both pairs of opposite angles are congruent. All right, show that one pair of opposite sides are parallel and congruent. So this is only if you have one pair. They must be both parallel and congruent. And last but not least, show that the diagonals bisect each other. So if you have these properties, or one of the properties, then you can go ahead and conclude that the quadrilateral is a parallelogram. So let's see what theorem we can use to prove that these are indeed parallelograms. In number 1, what I notice here is that opposite angles are congruent. And we have to have both pairs of opposite angles congruent. So if this one is 75, we can conclude that this one is 75 as well, because remember, consecutive angles are supplementary. So 180 minus 105 gives you 75. So this theorem is the opposite angles theorem. We're just going to abbreviate. All right, in number 2, what we have is we have that both sides are 10. So that means a pair of opposite sides are congruent. And you see the triangles there mean parallel. So we have one pair is congruent and parallel. So if you only have one pair of sides that shows information, it must be both things, parallel and congruent. You just can't have one, you've got to have both. And in number 3, we see here 73 and 73, so that's one pair of opposite sides, 98, 98. So we have opposite sides congruent. Next, number 4, for what value of x is the quadrilateral parallelogram? Well, if this quadrilateral is indeed a parallelogram, then consecutive angles are supplementary. So to make this a parallelogram, I would have to make those angles supplementary. And when you make them supplementary, x comes out to 20. So the only time that this quadrilateral is indeed a parallelogram is if x is 20. X cannot be anything else but 20. Number 5, find the length of the diagonal TV. So here's the diagonal TV, and we have to find length. Oh my gosh. So remember, to find length on the coordinate plane, we have something that's in the middle here. Okay, so that's okay. We're going to go ahead and we have another middle here. So we're going to build our triangle. So remember, to find length, we're going to go ahead and use Pythagorean Theorem. What allows us to do that, again, is that the graph gives us perpendicular lines here. And so we can create a right angle using perpendicular lines, and then we can use the diagonal here as our hypotenuse. So we just need to count a few lengths so we can do Pythagorean Theorem. So we have here, we have a half, 1, 2, and another half. So we're going to call that 3. And then let's count this one, 1, 2, 3, 4, 5. So now all we have to do is a squared plus b squared is equal to c squared. 9 and 25, 34. So x is equal to the square root of 34. There you go. So that's the length of your diagonal. All right. TV is equal to the square root of 34. Last but not least, number 6, the vertices of quadrilateral ABCD are given. Draw quadrilateral ABCD in the coordinate plane and show that it is a parallelogram. So let's first plot the points, and then we'll talk about how to do this. So A, -2, 1, -3. B is at 0, 5. C, 6, 5. And D is at 4, -3. Okay, show that it is a parallelogram. So we've kind of discussed this before. Anytime it says show or prove, that means give me mathematical proof algebraically using numbers. Prove to me that it is indeed a parallelogram. Well, there's a couple of ways we can prove it. The first way we can prove it is to say that the opposite sides are parallel. Well, how do we show the sides are parallel? So if we make this a side, BC, how can we show that it's parallel to AD? Well, you have to think of those as line segments. Parallel lines have the same exact slope. So a way you can prove that this is a parallelogram is to say, okay, well, the slope of BC and AD are basically the same thing, and what they are is 0. Well, you have to prove both pairs of opposite sides are parallel, so we have to say, all right, side CD and side AB, we have to show what their slopes are. So if we count their slopes, go up 1, 2, 3, 4, 5, 6, 7, up 8. So up 8 over 1, 2. If we reduce that, so both slopes here, 1, 2, 3, 4, 5, 6, 7, 8, 2. So both slopes of the other sides are both 4. So the slope of AB and CD are 4. So that's one way to prove that a quadrilateral is a parallelogram, is to show that the opposite sides are parallel. Another way you could do it is to find the length of these sides and show that the lengths are also parallel. So that's another option, but we're going to stick with this one for today.